Okay, so now we're going to move to the UTM coordinates. The U.S. military developed the Universal Transverse Mercator UTM grid coordinate system in the late 1940s. It covers the world with 60 longitudinal zones defined by meridians, longitude lines that are 6 degrees wide. ArcGIS has UTM zones available for the northern and southern hemisphere. These zones, like state plane, are good for areas about the size of a state or smaller. We're going to change a map's coordinate system to UTM, and we close this county state plane map and open the California UTM. Yay, we're going to California. Know that the California counties has geographic coordinates, and we can look up UTM zone using the same website that we use for state plane. And we will right-click on the county and California UTM and go to property and coordinate system. That we have WGS. We need to change it. Okay. Go to project system and then go to UTM and then go to North America, and we have to pick it's zone 11. 1983 to 1983 UTM 1983. Okay, it should be 1983. It should be, yep. Now they didn't update it here. So it's 1983 zone 11. So we will choose the 2011. And then we're gonna click OK. So in the contents pane, we're going to right click on the California UTM and go back to property again and back to general, and the display units, degree, minutes, and seconds, we're going to do play units, so meters, okay, and click OK. Use the California bookmark. Let's go to bookmark California and hover the mouse in the center of the state, which is right here. Move it a little to the left. Center is right here, and then oopsies, I don't need to do anything. Yeah. Okay, so then we will see the XY coordinates at the bottom that displays the UTM meters. So better to see meters because it's international. And on the project tab, we're going to go to options and go to project and then options, and we will go to map and scene and spatial reference. For spatial reference, we're going to go spatial reference, project coordinate system, world, and project coordinate system. How come it's not working now? Oh, choose. I have to choose and then project it. Alright, and then we will go to world, and we will do is WGS 1984. 1984 and web mercator, ancillary sphere, and click OK. Insert a map and then back and go to map. Can I just insert a map? Insert new map. Okay. Insert new map, and then we will do is insert a new map, add counties. We're going to map, add data. So where is county? Right here. County or counties. Add counties. Click OK. And then it's web locator, a preferred format for the ArcGIS, and check the coordinate system here. So right click on it, and then I will go to properties and go to coordinate system, and see it's web locator ancillary sphere. So it's the preferred format web locator. 1984 is the preferred format for ArcGIS Online. Then we're going to save our project. Click OK and click save, and then yes, and then close it out. So we're going to move to another one is for 5.4 vector data formats. So here we're going to review file formats commonly found for vector spatial data. In addition to file geodatabase covered previously, included are Esri shapefiles, XY data, and Google KML files, markup keyhole language. So we're going to examine a shapefile. Many spatial data suppliers use the shapefile data format, and Esri Lexi format from the early PC computer days for vector map layers because it is so simple. A shapefile consists of at least 3 files with the following extensions: .shapefile, .dbf, .shx. Each file uses the shapefile name but with a different extension. For example, we have a cities.shapefile, cities.dbf, and cities.shx. The HSP file stores the geometry and the feature. The DB file stores the attribute table, and the SH file stores an index of the spatial geometry to speed up processing. So next we will examine a census tract shapefile in more detail. Now we are going to open the computer or File Explorer window, navigate for our data. So which is right here. So our data is right here for chapter 5, and I might have to go back. Chapter 5, and we go to data. So look at the data, and we do have a console districts. Console districts, it's a shapefile for New York City, which is this one. And then we do have for New York City Council districts provided by the city's planning department, and shapefile have 7 associated files, including the 3 mentioned previously: shapefile, sh.x, and dbf, and also should have a project file right here, and then that contains the map layer coordinate system. And now we're going to turn this off, and we're going to import a shapefile into a file geodatabase, add to a map. We will use a conversion tool to import a shapefile into a file geodatabase where it becomes a feature class. So when we open this, we're going to save. I'm not going to save the then the project opens a map zoom to New York City with a PSC of NAD 1983 State Plane, New York. Long Island's FIPS is 3104 feet. And on the Analysis tab, we're going to click Tools. In the geoprocessing pane, we're going to click Toolboxes and expand Conversion Tools. And we're going to go to geodatabase. And then we will click feature class to feature class, feature class to feature class, and then complete some steps here. We will do is console districts is the input. Okay, tutorial, geodatabase. Nope. Okay, it should be in data. Data. Okay, console districts, and then output is the geodatabase, and output here we will still do console districts. Alright, and run the tool and close it after it finishes. And the shapefile will now be a polygon feature class in the geodatabase. So if we want to see, we go back to View and Catalog pane and Database, Chapter 5. Now we do have our console districts added here. Nicely overlay on the base map. Note that the state plane coordinates at the bottom of the map. So, and we can see, yep, that is the state plane. Okay. All right. So now we're going to add X and Y data. GPS units and many databases provide spatial coordinates as X, Y coordinates. They are easily added to a map as X, Y event files. So now we will use X and Y values from a table to create a point feature class of public libraries in New York City. So on the Map tab, we're going to click Add Data, Map tab, and Add Data. And then we will navigate to add our library. Where is our library? Oh, data. Okay. Okay, not here. All right. Folders. Folders, it should be tutorials. No. Okay. Alright, so cancel first. This is run successfully, and I'm gonna to add data. Add data desktop. Oh, I don't. Oh my god, I have to book data, and this is chapter 5. It should be in data library. Okay, now there it is. And now we have our library data, and we can just open it. We right click on this, and I don't like as usual, I don't like the floating thing. Okay, now, and let's see. And we scroll to the right to see columns, X coordinate and the Y coordinates, which is right here. And these coordinates are in state plane format for New York City. The X and Y locations are often obtained using GPS units and are in longitude and latitude format. So they do longitude and latitude first. So, and we can tell by, oh, this is difficult to tell. The format is not the one we usually remember. So then in this case, so X is the longitude and Y is the latitude, and the spatial reference should be GCS WGS 1984. It's a similar geographic coordinate system. And we're going to close the table, and we will display our library data. So right click on it, and we will display X and Y data. So here we have to pay attention because the latitude and longitude is inversely. The first part we're going to do is make sure that XY event layer, it's make XY event layer, and we're going to check to be sure that X field is X coordinate is X field, and Y coordinate is the Y field, and click current map vector format. So library and library layer and GCW, we have to change the spatial reference. So click the current map vector data format, which is right here, and current, okay, and then the reference will automatically set for the NAD. So 1983 state plane, New York, Long Island, Phipps 3104 feet. And then we can just run the model and the tool and close it after it finishes, and we can see where the libraries. The libraries will appear as pointing the map. This layer is temporary in the project, and the points should be exported as point features. We're going to export the library layer as which is right here. We're going to export it as a permanent feature class. The library point feature will automatically be added from the new location to the geodatabase